Friedgen from GeoSpart, and please introduce us about OSGeo-live.
And can I find my presentation somewhere?
Oops.
Is this yours?
Yes. Okay, F5. Oh, Control
no.
hash. Control hash. Okay, in the meantime, I will start introducing myself. My name is Friedgen. I'm from Belgium. I'm from GeoSpart, which is an SME. I have also a second hat. I'm very active in OSGeo, or OSGeo. And I'm going to talk about a project that we've did implementing Inspire using OSGeo-live. Okay. This is a bit difficult for me. I see, everybody know that yesterday there were other obligations and I have to talk to a camera, so I think there is a bigger audience than I can see, but thank you, because there are more people in the room than I expected, actually. Okay, let's start about Inspire. We are all in an Inspire conference, so normally I think that everybody should know what Inspire is. Inspire is a set of rules, and a directive is an objective to create a spatial data infrastructure. And we want to create a data infrastructure for the whole of Europe. And the aim to create that data infrastructure is to create an SDI at the European level, and that should help us in that should facilitate the policy making. Should also give access to harmonized information, and this among different parties. I'm telling all this information, but I'm even go further. There are today 34 teams already that we are implementing, and there is a roadmap that was decided and agreed upon by the European Parliament in 2007, which will last until 2021. And don't forget that there is an important deadline coming in November this year, where we have some obligations to execute upon. What we see is that more and more implementations are coming almost exponentially. And of course, together with all these implementations, there are more and more to-dos and obligations to the implementers of these infrastructures. So we need mature and well-documented tools. Okay. This introduction gave me some time for some people to enter the room in the meantime, but my plan was not successful. Okay, what was GRC, the Joint Research Center of Europe, has created some initiatives to help the implementers with their obligations. So they started to create a sort of platform. The platform is called Inspire in Practice. Actually, it's a registry with tools and with tools and solutions that you can use to ease your implementation. Today, more than 200 of these tools are already registered, and tool makers and solution providers are open to bring in their tools into the registry. As that registry and that platform is has a goal to the implementers, there is also focus for application developers and solution providers, as these are also the next users of these SDI systems and the data that we are providing. So Another topic I want to talk about is about OSGeo-live or OSGeo-live. OSGeo-live is what we call a community project of OSGeo. And then I can come to the question I always ask in every presentation I give. Who doesn't know OSGeo? I will repeat my question. Who doesn't know OSGeo? Oh, I'm happy that I have one. Are you honest? Yes. Okay. Because, well, I think I will have to change my story about presenting OSGeo, but I will, you give me the chance to say a couple of words. OSGeo is an organization, a non-for-profit organization, which was founded in 2006. And the founders were actually communities of open source projects. And we call it a community of communities. And what they do is to support the collaborative development of open source geospatial software and to promote its widespread use. Just a couple of figures. It's an organization that works globally but acts locally. And today we have more than 50 local chapters which are legal entities in several countries and that are bringing and spreading the word to the local communities, to the local people. Today we have more than 20 OSGeo projects. There are more than 200 mailing lists, more than 30,000 subscribers. To give you an idea, I think if you type in OSGeo on Google, you have more than 500,000 hits. And there are 300 charter members already in the organization, growing every year. And what is new is a couple of weeks ago, and that's the reason I'll have my t-shirt on, we had the FOSS4G conference in Paris, and there we decided to start the OSGeo local chapter for Europe. Okay. So that for my introduction to OSGeo. But back to OSGeo-live. OSGeo-live is actually an environment that you can use on a USB stick. And on that USB stick, you have more than 50 open source solutions together with data. And the only thing you have to do is to plug it into a USB slot in your computer, and you get an Unix operating system. All the applications are ready to test, to go, to try out. They are immediately useful. And on that USB environment today, there are several solutions. There are solutions for data transformation. There are solutions for using download and discovery services, but also to provide for the provision of the view, download, and discovery services. I'm calling names like QGIS or Degree or GeoServer, but more than 50. There are tools for metadata creation and even tools to use the data into applications. So why am I telling this? Because it could be a good starting point, as we have more than 50 FOSS projects included. And by the way, FOSS stands for Free and Open Source Software. As this can be used as a good starting point to do other activities. Today, this tool is used by a community called themselves Geo4All, and they are using it to bring educational material based on these open source tools to the schools and to the universities to learn and to teach using free tools and free software. They do that because it's easy. On the environment, there are pre-configured installations, there are sample datasets, and there is documentation. So now, open source and Inspire. The question is, how can we enable these communities in the open source geospatial technology, and how can we help them to support the implementation of Inspire? Well, we had a couple of talks, and we sat together, and as this environment is already a sustainable project for more than, I think, 7 or 8 years. There are more than 150 volunteers working on these tools. The idea of GRC was, if we could make a specific version for Inspire, shouldn't that be a good idea? And we worked upon that, and well, the first thing, if you want to reach a sustainable project, is that you have to motivate if you want to create a community, you have to motivate and incentive all the stakeholders in the community. So we have to motivate them to create these sample configurations. And we have to create an Inspire flavor of these projects. And to do that, well, it's easy to explain them what are the benefits. And there, the local European chapter could be a good help, because we can gather all these people in this community being in Europe and explaining them why it could be of interest. And we did that. We did that during this Phosphor-G conference in Paris 6 weeks ago. And we had some discussion with some people who were responsible for the several projects. And the interest is raised. They will look into it. So now it's time to continue on that process. We have still some other needs. Other needs are sample data. And I'm addressing my today to this audience, where I hope there are also data providers. And we have to think about good use cases, about good sample data. But we also need volunteers who want to test the environment and who want to distribute this environment to people who could use it, to spread the word, because it's open, it's free, it's easy to do. So, actually, the open source and Inspire communities could reinforce each other in that way. Coming to my conclusions of my presentation is that today we already have several tools available. They are registered. We have an environment that could be used. We could bring more out of this if we could motivate everybody to work together on this project. But of course, to motivate people, we need an ecosystem. We need to look into what are the benefits for every stakeholder in that ecosystem, and we have to address them with their benefits. We have to learn, we have to do the outreach. That was the start of my presentation. We have to explain what Inspire is and what we can do with all that harmonized data. And of course, it's not a one-shot process. We want sustainable processes. We want to motivate and incentive the people who are doing the work so that they will continue to do the work, that it will exist within 2 years, within 3 years, within 4 years, and that new tools could become on that live environment. And therefore, again, my call to action, also to this public, we need contributions, we need use cases, we need people who want to test the environment. We need data sources. We did some work around that. We looked at the gaps, what was missing, and tried to fix that and to put that in that live environment. If you want to read more about it, there is a link where you can find more information. And of course, if you want to be involved or want to collaborate or want more information, you can always ask to the people who were working on this project and are listed on this slide. So thank you for listening, and may the FOSS be with you.
Thank you, Dirk. Now it's time for a few questions, if there are. So floor is yours. Please, if anybody would like to put some questions for this interesting presentation. There is one.
Thank you, Dirk, for giving an interesting presentation, even if you obviously had a very short night. And allow me one question. You said you're looking for sample data. And how mature are your tools if you're still looking for sample data? From the list of contributors, I expect that you have a lot of experience. But without data, it's very difficult to test the tools.
Yeah, okay. So as the OSGeo-live environment exists already, I think, I didn't look that up, but I think it's more than 8 years old or something like that. It's the data that we use is, for instance, the Tiger database from the United States. There are several data sets scattered around on the DVD. The idea is to get everything packaged on one DVD or one USB of a certain size. So there are some limited restrictions. So what we should do to have a successful project is to think about a couple of specific inspiring data sets that could be used as use cases that we could bring into the environment within the data limitations. And of course, we can link to online available data. That's the next step. But it's important that we have an environment and that users immediately can find their normal environment, can do their normal work, and that we have use cases to learn them how to provide some data resource, to transform the data resources, to view them, and to eventually start with an application. The experience we have is already more than 20 years old. The data that we use is long time old data, but we don't have today an inspiring environment on that tool set. Is that an answer to your question?
Yes.
Okay, thank you.
Thank you. Any other questions? If there is no, so thank you again, Dirk, for your presentation. And
thank you.
I would like now to invite our next speaker. This is Helen Eriksson from Madrid. She will speak to us about Inspire Teams for process-oriented informations. So, Helen, the floor is yours.
Thank you. Hello, everyone. I'm an industrial PhD at Lantmäteriet in Sweden, and here I will present a study performed by Lars Harje and myself. We are, from a technical point of view, trying to find a more process-oriented view on the information flow in the planning and building process. And here we will also look how we can use Inspire themes in this process. Shortage in housing is a rising problem in many urban areas all around Europe. Many people are moving into the big cities, but the construction of residential buildings are often lagging behind. And shortcomings in the planning and building process can be one of these reasons. There are many phases in the planning and building process that need to exchange information, but this information is not always exchanged in a digital way, and this causes both problems with the duplication of work and can also be very time-consuming. Therefore, there are many ongoing projects today that try to increase the efficiency in the planning and building process by creating a more digital information flow where all actors involved can share this information. Smart Built Environment is one of those initiatives. It's a Swedish development and research program with an aim to improve the planning and building process by utilizing new digitalization methods and also creating new legal frameworks and new business models. This was started in 2016 and will go on for around 10 to 12 years. Today it has around 30 ongoing projects, and our study is linked to 2 of these projects, one for standardization and one for a testbed. Our study will take a process-oriented approach to the information flow in the planning and building process. And we think that the data can actually be divided into two different levels here. You have one level with phase-specific information, that is information that is only used within a certain phase of this planning and building process. For example, only in the planning phase or only in the projecting phase. Then you have this general information. And with this we mean information that is used in different phases. General information is often describing real-world objects such as buildings or roads. And this is information that also can evolve over time. And it can be described in different ways. For example, a building described in a geodata model is often used in the planning and real property formation phases, while a building that is described using building information model is usually used for the projecting and construction. The general information that is exchanged can be exchanged in both as data sets or as services, and using different formats depending on where in the phase that the data will be used, if it will be used for the planning or for the construction, for example. And here we think that also information from Inspire or extended Inspire themes could be of use as being general information. To complete this picture, there will also be a service level, including data certificates, quality controls and traceability, and an application level with user applications such as GIS and BIM application and visualization tools. Coming back to the Inspire themes, we have been looking at the Inspire themes to see which ones that might be of use in the planning and building process. And as you can see, we have found out that quite a few actually can be used. This is just a very first study, and we need to investigate this much more thoroughly to actually know exactly what can be used. But the question is if we can use the Inspire themes as is, or if they need to be extended with additional information that is required from the planning and building process. But as I guess most of you know, it is possible to extend Inspire themes with additional information. And as long as you follow the extension rules given in Inspire, the Inspire themes extended can also be seen as compliant with Inspire. And we have actually found at least one Inspire theme that could be used as is, and it's the planned part of the land use team. And in Sweden, we have problems with the detailed plans. Many of them today are actually still analog, and this causes problem in the detailed planning phase. It takes a long time to have those analog detailed plans. So a recent study has shown that to get all those plans digital, it will cost around 350,000 euro. And having an application schema ready like this, we might even use this one. So here we could actually describe our detailed plan as a spatial plan object. Additional supplementary information such as water restriction areas and soil plans can be described then as supplementary regulations. And the actual legislative document, the actual detailed plan, can be described as an official documentation. Our study will take a modeling perspective, and from this start with actually looking at what type of information and what types of models that are used in the different phases of the planning and building process. And then we will look what kind of general information that will be needed in all those different phases. And we think that an optimal solution would be if information about, for example, a building can actually be stored as one object. That is, one building is one object with a unique and persistent ID. And this object will evolve over time, it will get more attributes, it will get more detailed geometries, and so on. And those geometries should also be able to, we want to have a multiple geographic representation of those geometries, so that information from the same object can be used in the different phases. So more geometries that are not so complex can be used in the planning and real property formation phases, while more complex geometries and more complex attributes can be used then for projecting and construction. And as I said before, our study is linked to smart built environment, and this gives us the opportunity to use both information and results from projects within as input to our study. So when we are examining the current information and models in the planning and building process, we will actually be able to get test data from a specific construction site in a municipality. And this will help us. It will be easier to then, from a modeling perspective, analyze the information flow between these phases to see what is digital today and which is not, and which standards are used. And then, when we have this picture, we will analyze what additional information that will be needed to have a more digital and process-oriented information flow. And here we think that unique and persistent identifiers and versioning will be very important. Also, some other thematic information will be needed. We will also have a look into the building information models, BIM. They are already today using life cycle standards like the ISO PLCS. And this is interesting because we need this kind of information. So we would like to see how can geodata be linked to this, or can those kind of standards also be used together with geodata? And last but not least, how can Inspire themes and information from other existing services be used in this process? Right now, we are in the very beginning of our study. We are gathering a lot of information from smart built environment. We are getting process plans, information flows, detailed information about information deliveries, etc. So now we are studying this, trying to build ourselves a bigger picture of how this all fits together. And once we get this, we will start with this process of seeing what additional information that will be needed. In this process, we will also look at existing data specifications. In Sweden, we have both Inspire data specifications, but also more regional data specifications from what we call Svensk Geoprocess. Those specifications are often some sort of extensions of Inspire data specifications. And the aim with Svensk Geoprocess is to provide services on those data specifications with an aim to get both a more simpler and more efficient government services that, among others, can serve the planning and building process. So here we will look into this and see then what additional information might be needed for it to work well in the planning and building process if you want to take this more process-oriented approach. Well, in just a couple of years, we will have services from 34 harmonized Inspire themes that will be available from countries all over Europe. And a lot of time, effort, and money has been put into implementing all these services. And even if they are not perfect, they can still be used in many different cases. So how can we make the best and most use of them? Well, using them in the planning and building process might be one step in this direction. And thinking out of the box and at least thinking about using those kind of services when you need information for a certain purpose will most likely improve and add the use of those kind of services. Thank you for your attention.
Thank you, Helen. And we also have now a few minutes for questions. So please, if there is any question from the audience, raise your hand. Please.
Thank you, Helen, for your presentation. If you deal with planning, you depend very much on information that may change over the time.
Yes.
While what we realize when we look at Inspire is that the temporal aspect of Inspire is, well, it's not very well developed. At least in Germany, I know that we tend to provide snapshots, and that's very difficult, for instance, to receive persistent IDs from the source database when it's transformed to Inspire. So what's your experience in Sweden with that issue?
Well, with persistent identifiers, we don't have a problem, but I still think that the temporal information that is given within Inspire, I don't think that will be enough for this, and therefore I think we need some sort of extension of Inspire concerning this to be able to use it.
Thank you. Any other question? If there is no, then thank you again for your presentation, Helen. Our next presenter is Jean-Michel Zina from CLS. He will speak about standards and the business models. So, Jean-Michel, floor is yours.
Thank you. Good morning. I'm pleased to be here with you and welcome you to this session. So I don't know if we were with me in the afternoon yesterday to the plenary session looking to the future, but let's say one of the conclusions was that it is not obvious to find an evident business model in the coming data dissemination, and not only for data but also for algorithms. So I'm not supposed to give you here any unknown answer, but I just want to highlight the CLS experience in these transformations. First, let me introduce CLS. We are a subsidiary of the French Space Agency, which is active in 6 strategic sectors, quite related to the monitoring of the Earth environment. And from its creation, let's say that CLS is in charge of the dissemination of data. At the very beginning, CLS was created to gather and produce additional added value products over the Argos system. So the technical solution unit in which I work is in charge of all the SDI software development, and also now in the big data architecture approach. I would like to highlight this information and this story, let's say, through the oceanographic data experience CLS got over the past years. And I'm going to demonstrate how CLS turned to be a data aggregator. That means that the user will have the possibility to access to the data in a single access point with a robust, secure, standardized, distributed and interoperable service. Well, before, let's say, the emergence of SDI, let's say that the producers are in a standalone mode. They were producing data saying, hey, buy my product. This is the most scientific added value you can find on the market. Come on and have a look to my files, which are on an FTP server. For the oceanographic data, generally, let's say there is a first step of standardization, which is the use of the NetCDF. But let's say there is no constraints about the viable standard names and things like that. So people was taking the product as it is, the file as it is, and has to develop some software to be able to read it and to use it for the business. And then let's say that the European Commission tried to federate the access to the oceanographic data by setting in place the MyOcean project. So it was a first challenge to try to homogenize, thanks to NSPICE and OGC standards, the possibility to access to several data sets produced by many entities all over Europe. So it was a quite challenging step because everyone was in the previous version of the business model with FTP only. In the end, let's say that the CMEMS spatial data infrastructure can be considered as a data broker. This means that this is a single access point where users have a single login and password to be able to access to a web portal, which is public, and which display metadata information to describe the different data sets. There is also, let's say, the implementation in the front end of the Inspire services, discover, view, and download. And we have a backend for the service desk to manage the user registration and give them access to the required products. There is also one important component of this, let's say, core information system, which is the monitoring of the different entities, which provides products to the users. This to be compliant with the service level agreements set in place with the European Commission. So let's say we have now in production 43 production centers, which disseminate their datasets through 19 dissemination units. And let's say that we can make a synthesis of the CMEMS paradigm through these core components. The producer, this SDI, the producer is still in charge of the definition of its product, but now he has some constraints. He has to be compliant, let's say, with international regulation, not only, let's say, for the content of the auto-describe, let's say, the files, but for the naming of the variables, he has to be compliant with climate and forecast conventions, for instance, and he has also some operational constraints because he has to produce his products on time to be disseminated by an external dissemination unit. So he can focus, let's say, his core business on the production of to add the value and to make some expected enrichment of its products from the user point of view, and to describe as clearly as possible the way he is producing and qualifying the data to make it attractive to end users. So to be able to disseminate the data all over Europe, we have defined with the core interface some standardized interfaces. And one implementation that was deployed all over Europe was a CLS component, which name is Mo2. But we have deployed it in hosted and other data centers. So we have an obligation to make it as an open source code source so that people were aware of the code running on their environment. We also provide a Python script to facilitate the download of data in the CMEMS environment. So I no go further into much technical details, but you will find on the GitHub documentation the Mo2 architecture. Let's say that it is a layer above the threads component provided by the United Data community. And this component is providing some advanced services on the top of the threads component, which enrich, let's say, the operationality and the functionalities to download data. I don't go through all of them, but if you have any question, I will be happy to reply. Then we are also pushed by the standard, and we have implemented lately the WCS 201 interface in this component, and also driven by the user constraints. And there are a lot of downloads, which can be a huge amount of data. We have to restrict the volume for per request. and especially due to network constraints, because as you know, some proxy timeouts can cut your session when you are downloading. So we introduce, let's say, an asynchronous mode to be able to download large volumes of data through an HTTP REST API. Then Moto is also of interest to get the description of the NetCDF content. Automatically, you will be able to retrieve the description of the variable, the time coverage, and the different depths if it is 3D data, for instance. And this will help to populate the metadata and have a consistency between the catalog and the data. So now it is not the last step of the transformation, because we are still, let's say, at the broker level. And let's say, according to the user's needs, CLS turned to be a data aggregator. What does it mean? It means that with the different Copernicus entities, we have the user have to provide several credentials to be able to download a data for land, for marine, or for maritime, or any thematic data. So CLS is now deploying a Motu instance per data provider, so that the user can download its data in a single place. There are so many data sets, so many catalogs right now in so many initiatives and projects that it's difficult for them to enter into catalogs and find the most suitable products for their business. So thanks to CLS expertise, we are helping us to find the most suitable data set for them. We are able to copy a local copy of this data, or extract a subset of data locally, and provide them a single access point to their data. So if you have NetCDF products and you would like to offer such services to your users, to your end users, please contact us, or feel free also to use the Motu components to enrich the potential of the downloads for your products. So now CLS is integrating the products for the CLS group. We have several entities all over the world, and it's quite an interesting step for us to be able to give to CLS users a single access point to this SDI, which name is the data store. So here is, let's say, the story of CLS compliant with the user's needs and the standard constraints. Thanks for your attention.
Thank you, Jean-Michel. I propose to stand for possible questions from the audience. There is Alexander.
First of all, thanks for the presentation, very interesting, and the product motto that you showed is something that I'm definitely going to look into. My question is related to the issue that a lot of the marine data is actually observation, right? Being it moving or fixed position. I was just wondering, how do you handle the observation data? And do you plan to, for example, implement OGC service standards such as the sensor observation service?
Well, this was one of the job of one of the partners in the maritime community, and it is the Ephemer, which has developed, let's say, the oceanotron component to deal with all the in situ data. So it is not, let's say, implemented in Moto currently. It is, let's say, one of the CLS projects to provide also a solution, maybe with Moto, but currently it is implemented by the Ephemer component. And it offers all the OGC compliant services for extract, view, and so on.
Thank you. There was another hand over there, so, or not? No. If there is no question, then thank you again, Jean-Michel, for presentation.
Thank you.
Our next presenter will be Simon Jurka. he came instead of Christopher Stetch, who is written into the program, but he has excellent reason not to be with us today. So Simon came from 52 North and will present us presentation regarding data processing. So floor is yours, please.
Okay, thank you very much for the introduction. I would like to bring up a new topic regarding the enhancement of Inspire infrastructures by processing functionality. So if we look at most compliant Inspire service which we have at the moment, we are focusing on data discovery. So for example, using catalog services, data access through different types of download services like the WFS, Atom feeds, WCS, or even Sense Observation service. And we have the portrayal functionality, for example, delivered by the Web Map service. This is already a quite comprehensive infrastructure, but at the moment there is not really much about sharing processing functionality like algorithms via the web and do some added value processing of the data. So there are some application patterns where this may become relevant. So, for example, you have more and more observation data or geospatial data becoming available with the new SOS and web coverage services, download service, technical guidance. We get novel data sources which allow us to basically get more up-to-date data, put this into more comprehensive information products that can be derived from this available information. And basically this will add a lot of value on top of the data which is available through Inspire and allows us perhaps also to generate new business models with the data. So what I mean with this is illustrated a bit here in this slide. So we have a set of Inspire compliant download services which deliver data of any kind. Then we have some kind of processing components. So if you look at the data service and invoke services, that goes into that direction. And then in the end, we get an information product, like, for example, an interpolation of some data, or we may even feed prediction models with incoming data streams, combine that with other geospatial information, and then derive products, perhaps warning applications, etc. That's one thing, so adding value on top of the existing Inspire data sources. And another topic is the sharing of algorithms that people may develop. So there may be people working on interpolation algorithms based on top of some Inspire data sets. People are perhaps doing some other kinds of model or derivation of information. And they want to share this functionality via the web because it's a bit following also this open source idea. If you develop one approach, one software once, you may share also the functionality, not only the data that you have developed. And also here, such processing services could play a good role in helping people to share functionality they have developed and make that available also to other users. And for that purpose, in the OGC world, there's already a specification which is fulfilling exactly this type of application pattern. And this is the OGC Web Processing Service, in short WPS. This is now available in version 2.0, which has been published in 2015. And if you look around, there are already quite a lot of different WPS implementations out there which can be used. There are commercial applications, open source implementations, so really a lot of options to implement this. And this standard basically offers a model and an approach how to share such processing functionality via the web. So for example, you get ways to determine what are the inputs, what are the outputs of an algorithm, what are the operations for invoking such a processing workflow, And even in many cases, you may have situations where you have asynchronous communication necessary. That means you may have long-running algorithms which may take hours or days even. In that case, you need some kind of initiation of the process and then an asynchronous notification as soon as this process has been completed. Also, that is provided and described in that standard. So at the moment, we have key-value pairs, so HTTP GET-based binding as well as an XML-based interface. So let's look a bit more into this standard. How does it work in practice? So on the one hand, you see here the clients. The clients are maybe desktop applications. So for example, in GIS system, there are even clients for WPS available in GIS tools. You may have web applications where you share some functionality via the web, or you may even deal with in larger workflows within spatial data infrastructure, service-oriented architectures, where the WPS is just a component linking other data sources into outputs. On the other side, you have the WPS server, so the processing server, and this server offers a series of different algorithms. They are called processes here that you may invoke. So there may be one process for calculating a buffer, there may be another process for calculating an interpolation, etc. So one server may offer different types of functionality. So if you are then implementing a client application, as for all OGC services, you will first send a so-called get capabilities request. And basically this, among the other typical metadata, delivers to you a list of processes that can be executed by the server. So there you will have an entry for the simple buffer algorithm, for example. Then you may have a more detailed look at these processes by selecting one of these processes from the long list and then issue a described process request, which gives you more details about this process, some textual description, and as well as, most importantly, a description about the inputs of that process. So which data does it need to calculate something, and what are the outputs that I get from that process. After you have determined what you need to provide to the server, then you can call an execute request, which starts the execution of this algorithm, and then sometime later you will get the processing result. So what you see here is, again, the solution. So you have, as this processing tool, deriving other data products, the WPS as the mediator, taking data from a source and publishing it again, most likely also again through OGC Inspire compliant download services, at least if possible. To illustrate this now with more practical background, I would like to quickly introduce one project where this WPS technology has been already applied. And this is a project which has been running now for about 2 years. And in this project, we are dealing with the monitoring of river dams, where different parameters like the stability of the dam, so more specifically the water intrusion into the dam are measured, information about the water level in the lake, which is limited by the dam, etc. So we had different needs for analyzing data in that project. On the one hand, we wanted to detect if there are some gaps in our time series, so pretty simple time series analysis. Then we had to do some spatial interpolation about humidity measurements in the soil, and then also some predictions of runoff water being released from that dam. And that has resulted in a service-oriented architecture, which is pretty much aligned to the principles of Inspire. So we have here, doesn't work. So we have on the left-hand side an OGC Sense Observation Service delivering different types of observation data, in this case water level measurements, weather information, and then we have coupled to this observation data source a web processing service, which is deriving different types of information. So we have on the one hand a linear regression model for doing some time series analysis. We have TALSM NG, which is basically a specific model for predicting the runoff from a dam. So that has been encapsulated by such an WPS server. And finally, also some spatial interpolation algorithms, which are also provided through that WPS server. And then in the end, we have coupled this to a certain set of applications. For example, also through a REST proxy into web-based lightweight applications. And in the end, this allowed us to not only consume the data in an Inspire style, but also to do something with the data and derive further information. So, coming to a conclusion, we have seen with this processing service two application patterns. One thing is adding value on information provided by Inspire download services, and the other one sharing processing algorithms and data processing functionality in an interoperable way so that it can be reused by a community of users. At the moment, this is not really actively covered in many Inspire implementations. There are some basic principles already in the architecture. But what we would propose here is based also on our experiences that the WPS may be a valuable enhancement for future Inspire activities to share such processing functionality, and perhaps in the future that may even be something to think about, like a technical guidance how to apply the WPS in the Inspire context for generating even more value out of the data shared in the Inspire framework. And with that, I would like to thank you for your attention, and if there are any questions, I will be happy to answer.
Thank you. So again, we have opportunity to left some time for questions from the audience. Please, if there is any question, there is a microphone available. No question. In that case, I would like to thank you again, Simon, and invite the next presenter. Next presenter is Sampo Savolainen from Spatial. He will speak about catalogs and novel approach regarding the catalogs. So, Sampo, floor is yours.
Thank you. Of course, computers. Who knows how this works? Okay. Thank you, and it's great to see so many of you after the dinner last night. I will be talking of a subject which in some senses has been resolved quite a long time ago, catalogs, but there are some issues with catalogs that Canada, the Natural Resources Canada has had, which we have been tackling, and I'm going to present the results from that. So first of all, why do we care about catalogs? Very quickly, it's important to know what data we have. That's the core. We have to understand what data is available, what metadata there is. The SDI cannot reach its full potential if we don't know what data is in there. So it is crucial to what we're doing. And for Canada, Natural Resources has had a catalog. It was called the GeoConnections Discovery Portal. This had been a manually collected catalog where there was a team of people who maintained it, but unfortunately for them, it was too expensive to maintain, and the project was decommissioned. And for this, you have to remember that for a catalog to be maintained, it needs quite a lot of work. It's not enough to put everything inside once. It has to be maintained, and especially when it's manual work, there are different sorts of problems. There's old data, there are data entry issues, and so on. It requires active maintenance, and for a larger country or a larger SDI, that is a lot of work. And then that is only a catalog. There are other factors which could be included in it, but those come at additional cost when the catalog is maintain manually. And and I, for one, think, and the Natural Resources Canada also thought that this is something that where we should investigate whether automation could be used to produce the catalog itself. So they started a project in 2016, and they looked for a contractor who has information in this area, and they selected us mainly because we already have a large directory of spatial web services. We have, I think, 54,000 spatial web services at the moment in our databases. And what we built was something which was broader than what they had before. It was more up to date, and they have quality of service information in their catalog for people to take advantage of. And how we do this is by a process which does not start from Canada. It starts from exploring everything that there is online. This means that we have mechanisms which go through CSWs all over the world. We use Google, we use open data platforms. We added a few Canadian-specific CSWs and their CCAN repository, as well as some reports and assessments that they had done previously to add into the crawler system. And now this creates a worldwide catalog of services. We don't care whether they're Canadian, whether they're Finnish, whether they're Swedish or Tanzanian, we put them in our database. And what we do then is that we monitor those services so we know whether they work or not, and we make sure that we have up-to-date descriptions of those services. And this all happens automatically. And then the next step was to produce the Canadian catalog. So we created a method to filter the services which are relevant for Canada, and filtered out from the worldwide database something that is relevant for Canada. When the project was decommissioned, they had 350 services in the original catalog. At the end of this project in 2016, the catalog we produced for them had 1,722 services. So the catalog improved substantially, and they have information that they didn't have before. They had quality information, they had up-to-date layer information, and so on. They produce the catalog in a method that people can search it. They are looking into other ways of publishing the information. They have all the data, and they can produce what kind of catalog they want. But this method is not something that is only for Canada. This method can be done for any SDI. And the Natural Resources Canada, the people involved in this project, are also involved with the Arctic SDI, which is an effort to build an SDI for the Arctic area. So to produce information to help research and other activities around the Arctic area. And we expanded this method. We added some Arctic SDI specific sources into the harvesting to further improve the database that we have. And then we created a more elaborate method of figuring out what services are relevant for the Arctic SDI. And where in Canada, we simply chose to select those services which are under the Canadian domain, which is very naive, very simplistic, but works very well for their case because they are interested in the services and the data produced by the Canadian government. So actually that naive filter is very good, but for the Arctic SDI, it's much more complicated. So we have looked at a method of choosing multiple variables, choosing different scores of different methods to score these data sets and services. So looking simply for the words Arctic SDI, if it says Arctic SDI, that's very important. There are some geographic names which are very unique to the Arctic area. We look into whether the polar projections are used. If the polar projections are supported by a service, it's most likely relevant to the Arctic. And also we look into spatial relevancy, and then we produce a score based out of this. Just as a quick pointer, spatial relevancy is not just whether the service overlaps the Arctic or not. It's important to give a good score to those services which are only in the Arctic or focus mainly on the Arctic, instead of giving a score of yes, this WFS service which spans the entire Earth does also span the Arctic, so it would be relevant, but it's not. It's actually not. So we have a method for doing this as well. Just so you know what this sort of looks like, it's very highly technical, lots of numbers. There are a lot of services which get these scores. There's a method of how these scores are weighed to create a list. We're still in the process of figuring out how exactly the scoring will work, but just the first implementations of the scoring already showed us that we are able to find very relevant data for the Arctic. So with this, we're able to produce the catalog for the Arctic SDI. And what's important for the Arctic SDI is also that there's a lot of data sets which are produced outside of these countries, outside of the Arctic area countries, which are actually relevant for the domain. So it's important for them to have a tool which creates a catalog that not only catalogs those countries or organizations involved in Arctic SDI, but also all the data that can be relevant in that area. So now they're able to see if they have duplicate data, whether they have gaps in the data. They're able to give better information to the researchers. They can measure the KPIs of the Arctic SDI. They can see whether the Arctic SDI is actually making improvements and and whether they're on track to their goals as a team. The current status with this project is that next we're going to be making this data into the ISO compliant metadata and putting it into a GeoNetwork of theirs so that they have access to it and they can start using the data, giving it to the researchers, and that way we get a positive feedback loop. Because at the moment, the way that we are selecting the services is maybe not the first attempt, but let's say the third attempt, and I'm sure that we can improve on the method that we choose the relevant data. But we first have to get the catalog to the users so that we get feedback so that we can start improving the system. There's also one possible method of using this data as well, or this method, excuse me. There's the Arctic Spatial Data Pilot in the OGC, which has already got, like the pilot has been done, and during that pilot they created a catalog which was valuable for the members of the project, but there's no one to maintain this. So it would be valuable if someone could maintain the catalog that they produced, and this could be one method of doing that. So key takeaways: catalogs can be produced automatically in automated mechanisms. They can be better than manually maintained catalogs, and we have better coverage of the catalog with less resources. And the critical task to do this is that you have to first have the global directory, something where all the services, everything that you can find online is produced in and maintained, so that there is this large group of services and data that you filter out from. Then you have to design, of course, a filtering method, and then you have to ensure that there's a feedback loop so that we can improve the method that we do the service selection on. Now, how this could relate to Inspire. On Tuesday morning in the Copernicus session, there was a presentation on results of an experiment where they took the Inspire GeoPortal metadata and looked at, okay, we have the metadata that we're interested in. Let's see if the metadata has actually a link to a download service. Okay, not everyone had it. Okay, then we had a group of download services. Then they checked for compliancy of these download services and did other few compliancy checks. And what the end result was that they found 0 fully compliant download services for the interesting WFS services out of the Inspire GeoPortal metadata, which brings into focus the fact that if a catalog is maintained by hand, it might not actually be functional. It could be very functional to humans and especially experts, but for a piece of computer software to access the Inspire GeoPortal and find metadata and find actually the services providing that data, it might not work because the metadata has to be exact. So in my opinion, it's a job better suited for automation and for machines than for people to do. And also, Jiří Hradek had an interesting presentation where where he showed mechanisms on how just the abstract of a data set could be used to produce metadata. To say in which areas is this service or this data set applicable to, and so on. So there are the beginnings of methods of creating a lot of automated tools to provide functioning catalogs which actually show what is available and what is usable. And that's what I had today. Thank you.
Thank you, Sampo, for an interesting presentation, and we also now have a few minutes for questions from the audience. There is a question behind, please.
Hi, I want to know if you use some keywords when you do the harvesting. If you use some keywords to filter all the information that comes from another catalogs.
For the CSWs, I don't think we use any keywords for the CSWs, but of course for Google we have to use keywords. Yeah.
I don't know if I haven't understood properly, but I think that this catalog is made with metadata of other catalogs also.
Yes.
Isn't it?
Yes.
So when you connect with that catalogs, for not catching all the information, just the one that is related, for example, with the Arctic? How do you do it?
Actually, we do it the other way. So when we harvest a catalog, we try to get everything out of that catalog. We don't care whether it's Arctic, whether it's Canadian, whether it's Inspire, what it is. We just want everything. we want the worldwide database in this picture to be as large as possible, to have everything, so that when the need comes, we can produce a catalog, we can look into the system. And this also means that if we would produce now a catalog for Italy, for example, we have historical data of the availability. We can say a lot more than just what the metadata says. And we have historical records of the services. So we don't have only the newest versions, but we also have the previous versions and the version before that and so on.
Okay, thank you.
Thank you. There's another question, Alexander here, and after.
I find the approach really clever. I think it will resolve and improve the quality of catalogs if we really reverse the whole issue, if we start looking into the web first and then construct catalogs. But I'm thinking it's creating another level of issues potentially, and if you can tell me, for example, how do you handle the copyright? Because if it is a homegrown manual, then you will be absolutely sure there's no copyright issue. You can cascade the services, you can create your own content. But I'm not sure that's the case if you're really crawling and discovering and feeding everything into your own GeoNetwork or other catalog solution.
That's an excellent question. That's something we need to address almost right now, that when we start to produce the metadata, the ISO metadata for the Arctic SDI, so we have to look into that. If anyone has experience with copyright on copying metadata, please let me know.
But it's bad experience.
I don't want to hear about those.
Okay. There was another hand behind.
Yeah. Also, thank you for the interesting presentation. Opinion and question. First, as an analyst, every time I have to use any Inspire services, I start screaming, because we have, of course, everything standardized, but we have hundreds of different flavors, nothing works. Accessing from programs, these services is not really easy, but if things go more or less standardized, as you are describing, using automated pre-processing of data, I think that there will be a race of platforms that will be like a open data portal of the European Commission, where you have defined APIs to which I can nicely connect with my Python scripts, get data directly. Do you see it would be one day after the year 2035 possible that even the poor crowd with just non-GIS, but very much needing GI data available?
It's a good question. What comes to accessibility of the data, this method, when we produce a catalog, the catalog will be a catalog of usable services, because that's what we always do. We check the services every 5 minutes. If they don't work for us, if we can't access the service, it's not included in the catalog. So in that sense, the catalog produced this way will be, for the data user, it will be higher quality. But for the question of whether Inspire services, the theme schemas, the complexity of the data can be improved in a way that normal application developers can use it, that's a very difficult question. But maybe someone could create some sort of overlay on top of that, on top of it. Once we have harmonized services, there could be a harmonized service which creates simplified addresses or simplified administrative units and so on. Perhaps, maybe it could be built on a catalog like this.
Okay, thank you, Sampo. Is there any other question from the audience? If not, then thank you again for your presentation.
Thank you.
So, ladies and gentlemen, we still have a few minutes time because coffee is not served yet. For any general questions, if there are, for any discussion, if there is raised up during all those 5 presentations. If there is no interest for this, then in that case, I would like to thank again all of the presenters, Dirk, Helen, Jean-Michel, Simon, and Sampo, for time and for presentations, and enjoy your break. So the session is finished. It's closed. Thank you.